This is CPM Calculus Chapter 3, number 32. So Jasmine rolled a ball down a steep ramp. So here's a steep ramp. Okay. Jasmine rolls a ball down the steep ramp. Okay. And got the distance function s of t is equal to 2.3 t squared, where t is measured in seconds and s of t is measured in feet. Sketch a graph of her distance function on your paper. Then carefully approximate the speed of her ball at t is equal to 3 seconds. Okay, so let's do the sketching first. So we know our function is s of t is equal to 2.3 times t squared. So if we sketch this graph, we're going to start here at time is equal to 0. So this is time. And over here we have her distance, and it's measured in feet, and time is measured in seconds. Okay, so to sketch this, we know at 0, we plug in 0 into t, and we get 0, because 2.3 times 0 squared is 0, right? We plug in 1, and we're going to get, so let's just mark a few of these. We get 1, we plug in 1, well if t is 1, we get 1 squared is 1 times 2.3, so we go up to around here. Get 2, let me just mark these, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, if we plug in 2, we get 4. 4 times 2.3 is about 9.2, so it's already above where we can't see, right? So here's a sketch of, let me make it a little better, a sketch of our graph, right? And I start at 0 because that's where time starts. Okay, so there's a sketch of her graph, of her distance function. Now approximate the speed of her ball at t is equal to 3. So at 3 seconds, right, we know we're all the way up here. Like, here's our graph, it's all the way up there. Okay, so let me zoom in. Let me sketch it a little better. Okay, I'll just make this go 10, 20, 30, 40, 50. Right? And then this still go 1, 2, 3, 4, 5, 6. So I know at 1, it's going to be like right around here. At 2, it's going to be right around here. 3, we plug in 3, we get 9. 9 times 2.3 is around here. 4 times 4 is 16. So like if I plug in 4 into t, 16 times 2.3, let me bring out my calculator, just 16 times 2.3, 36.8. So I'm around here, right? So it's going to start looking like this, right? If I plugged in 5 times 5 is 25. 25 times 2.3 is 57. So yeah, I'm off the chart. Okay. So that's a better sketch because I want to look at the ball where the seconds is 3, so the time is 3. So I know that since this is feet, right, this is feet, or distance in feet, and this is time in seconds. So if I want to know the speed, it's going to be the change in her distance. So speed is equal to the change in her distance over the change in the time, right? And that's the same because this is our y-axis and this is our x-axis. So this is the same as delta y over delta x, but we have, instead of y we have s, instead of x we have t. Okay, so it's just going to be the slope function. So that's equal to the slope, right? So at 3 seconds, we know that the slope is going to look something like this, right? This is the tangent at 3. And so what is the slope function? So what is s prime of t, the slope function? Slope function, right? S prime of t, well, remember from the power rule, we have this is in the form of the power rule, right? We can use the power rule. We bring down the exponent, so it's 2 times 2.3 So that's equal to 4.6 times t, and then we take 2 minus 1, so that's just t. So this is the slope function right here, okay? So if we plug in 3 seconds, so at t is equal to 3, s prime, right, because it's our slope function, with the input of 3 equals to what? Well, it's 4.6 times 3, because that's t. So bring out your calculator, 4.6 times 3, and that's 13.8. So we get 13.8 is our slope function. Remember, the slope function is defined here as the slope, which is our speed. So we know that the units are going to be feet per second, and this is the ball's speed at time is 3 seconds, 13.8 feet per second. Okay, this ends CPM Calculus Chapter 3, number 32.